I'm going to pull up the identities. Now, remember, I want you, and I got some, and I'm going to make this test, probably it's going to be in class. So, because it's identities and it's very important. So, we're probably going to have an in-class test with this test. So, I'm going to give you the cheat sheets, because half of you probably don't even have a cheat sheet because you have to hit like 3 buttons to print it out. So, I'm sure probably, let's see, there's probably 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's 20 people in there. Probably 5 of y'all have done it. So I'm going to make sure that I have them. I got them in my office, and I'll bring them to the test whenever we have it. I'm thinking I might give just a test on just the 3 sections. 9.1, 9.2, and 9.3. And these are the identities we're going to cover today. So you might want to go ahead and start writing them down. And I'll tell you what they are in just a second so you can remember. I'm going to go ahead and put them all on the board. Now, why do you need to know these? Is anybody ever going to walk up to you and ask you while you're pumping your gas, you know, can you tell me the half angle identity? No, nobody's ever going to ask you these. All right, it goes to 2 things. It goes to manipulation of an equation, and it goes to rewriting an equation. All right, those are 2 important things that you have to be able to do in calculus. All right, and it also reinforces plugging and chugging, plugging in angles and plugging in numbers. So there's 2 or 3 things that the identities teach you, but walking up to somebody after they're out of trig and, do you know this? No, nobody's gonna. It's the whole process of rewriting, manipulating, and plugging and chugging. So let's put the last one up there. And like I say, if you print out that identity sheet that I told you to print out the first week of class, that the 5 people did and the rest of y'all didn't, all of these are on there. And the best one to print out is the green and white one. Did anybody in here print it out? I thought somebody did. Okay?
I did.
Okay, thank you. How long did it take you? It's a lot of work, isn't it?
Yeah, it took me like 3 days.
Yeah. So we're going to go over this, and this is 9.3. And what I'll do next week is we'll go over homework questions, because I'm going to go figure this out, because I'm getting questions sent. There's 110 questions in my inbox, and they shouldn't be in they should be in the 110 folder. And the 111s.
Thunderbird.
Yes.
We can't see anything. There's no board.
Okay, hold on. I'm intentionally leaving y'all out.
Okay.
Whoever said that, I don't. There, how about that? Was that who said something? Was that the Pendleton campus that said something?
Yep.
No.
I didn't think so. Must have been the Easley campus. Okay, now can you see?
Yes, sir.
Okay, write those down. Now, of course, if you have the identity sheet, you don't have to write them down, but there they are. The first one is called the double angle identities, double number identities. They're the ones in the top left-hand corner. And then you got the product to sum and the sum to product. And the last one that I pulled up is the half angle, I believe. Yeah, half number identities. Now the reason you need to write them down is because whenever I go over these examples, and basically the examples are 10% identities and new stuff, and the rest of it's algebra and plugging and chugging in math. So you're not talking about very difficult problems here. You're talking about making sure you know what identities and when to use them, and then how to plug and chug, and then after you plug and chug, how to simplify. That's what you're doing. It's not a big deal. And I'll go ahead and let you write down the first one. The first example we're going to do is well, let me rewrite it. I want you to write the sine of 2 theta and the cosine of 2 theta. And the sine is equal to 2/5, and the cosine is less than 0, so that means that it is negative. Okay, so this is what you're going to be given on a problem like this. Now, what is the first rule that I've taught y'all in trig? Find out what? Where you are. So, with that sine is equal to 2/5 and the cosine is negative, you need to draw your quadrant and you need to find out where you are. Write those identities down. See, it'd be a whole lot easier if y'all follow what I said and printed out that trig identity sheet, and then none of y'all would have to write all these down. So where is this one going to be? If you have the sine is equal to 2/5, but the cosine is what? It's negative. Okay, let's draw our handy-dandy quadrants. Because I guarantee you there's somebody in here, not in here, but in this class, meaning 4 campuses, that don't know what that means. Well, if the sine is positive, all students take calculus. If the sine is positive, then it has to be between the first and the second quadrant. Everybody agree with that?
Yes.
Cosine, it has to be what?
Negative.
It has to be negative. So that means the only place that is positive is these two. Okay? So let me say this again. The sine is positive here and here. Everybody with me?
Yeah.
The cosine is positive here and here. So if I want the cosine to be negative, I'm going to do it in red. The red means the cosine is negative. Where does the sine is positive and the cosine is negative overlap? Second quadrant. So you're talking about the second quadrant. So I want you to draw that triangle in the second quadrant. Now you can do it by the identities or you can do it by the Pythagorean theorem. I don't care. All right? So we're going to take our handy-dandy eraser and we're going to erase this one, and it's probably going to take off half of the... No, it didn't. So it's going to take off the identity there. If I erase that little red mark, it'll take that identity out, so I'm not going to do that. So I'm going to draw my second quadrant, and I'm going to put a triangle here. And that triangle is going to be Oscar had, so that would be 2 and 5. So therefore, this is going to be the square root of what?
21.
21? Yeah, 25 minus 4 is 21. And it's going to be negative. Now, you know what the cosine is. All right? Now, why do you need the cosine and the sine? Well, look up here. Okay, sine of 2 theta. Cosine of 2 theta. Well, you can use either one. I don't know which one I used. I think I used this one. Okay? So you have to have the sine and the what? The cosine. The sine is equal to 2/5. Therefore, cosine is going to be equal to what? Negative square root of 21 over what? Now, you got what you need. Plug and chug. So, the first thing you need to do is find where you are. I did that by finding out what quadrant I'm in. The second thing I do is I find the sine and the cosine, and in some cases you might need the tangent, depending on what the question's asking for. And you can do that by the Pythagorean identities or the Pythagorean theorem. Most people use the Pythagorean theorem because they don't have to do all that remembering. Okay? Then after you find the sine, cosine, and tangent, you plug in what? Chug. And that's what a lot of these you're going to be doing. But do not make this difficult. When it's difficult is when you have to memorize these things. And we don't make you memorize it because you don't memorize things in real life. You go to books and charts and calculators and computers. So the days of memorizing stuff like this is over. So let's take our sine of 2 theta, and I'm going to erase these if y'all don't mind. Has everybody finished copying? Pendleton, are you finished?
Yeah.
Okay, got a yes. All right. Easily. You finished?
I've got 2 more to do.
Well, hurry the hell up. No, I'm just kidding. Oconee, are you finished?
Oh, sorry. Yeah, I don't need them.
Okay. So we're just waiting on Easley then. We'll
Yep,
just sit here
me.
and wait and hold up class for Easley. Anderson, are y'all finished?
Yep.
Okay. I'm going to take the top 2. Can I take the top 2 off?
Yeah.
Okay. I'll take that one off. Y'all are impressed, aren't you? And I'm going to take that one off. Tell me when you finish with that last one.
Just finished it.
Okay, good. All right. So I'm going to take my handy dandy sine of 2 theta, and I'm going to write it out. Sine of 2 theta is equal to 2 sine cosine. And you can put the A's if you want to. I don't really care. All right. So we've got the sine of A is 2/5, so that's going to be 2 over 1 times 2/5 times what? Square root of 21 over 5.
Negative.
And now you just have to what? Do math. And that's what this is like. 1, and again, 1, you find out where you are. 2, you find out which property to use, and when you do that, you basically find the sine, cosine, and tangent, or you basically find which identity to use, and then 3, plug and chug, and the chugging part is right here. So that's going to be 4 times square root of 21 over what? 25. Now you do the cosine. And you can use either which one, but I think I use cosine squared. Let me check to make sure, because all of them are derivatives of each other. Yeah, I did cosine squared. So you do cosine squared, or cosine of 2 theta. The cosine of 2a is equal to cosine squared a minus sine squared a, which I'll go ahead and plug and chug. I'll plug for you. That's going to be 2/5, or I'm sorry, negative square root of 21/5 squared minus what? 2/5 squared. Now, there's going to be some of y'all that are going to choke a little bit. Because of what? Well, we got a negative in there, and then we got a square root symbol. So I'm going to find a way to screw this up. Right? Well, what's any kind of negative squared? Positive. And anytime you square a radical, it takes out the radical. So don't screw that up. 21/25 minus 4 over what?
25.
And that gives you 17/25. Now again, if you take out memorizing the identities, how difficult is this? It's not difficult at all. Unless you can break an anvil with a banana. All right, let's do another one. And next week, we're going to go over nothing but homework problems and examples. So think of next week as practice. And I need you to send in questions also. And please send them in, don't send them in like 2 minutes before class when I'm preparing for class. Send them in like, the morning of or the night before, okay? Don't send them in like 5 minutes before class.
Mr. Hubert,
Yes.
so the homework's not due tomorrow?
Not that I know of.
It's
Well, that's it. Are we? Okay, we're going to have a test tomorrow. Okay, so what am I probably going to do?
Never mind.
Oh. Y'all just like break an anvil with a banana.
It's the same as last time. We're not done with the material.
Yeah, we're not done with the material. We're not going to have it. It's okay. Some of y'all have been conditioned. And one of my students enlightened me. And I was advising, and my student said, don't blame the students for not communicating. They're not communicating because they're conditioned that way. And I didn't think about it. They're conditioned. Some teachers don't like for you to ask questions. And some teachers don't let you talk in class. And you go through 12 years of that, and you come to Hubert's class, and I ask you to do everything the opposite. Maybe that's why I have a good retention rate. I don't know. But y'all need to get off the conditioning wagon. And, Pavlov, y'all need to get off that wagon too and quit being conditioned and communicate. Because this will be in class. Okay? And if you are a little bit rusty on these, you need to start asking questions because I don't want to fail you. I mean, I don't want to do that, but squeaky door gets what?
Wow.
OIL, yeah, or grease. And for some of y'all that have been conditioned, you need to get out of that because it's not going to help you. So, and that's all I'm going to say on that. Cosine of 3x. And in terms of cosine, I just want you to rewrite cosine of 3x in terms of cosine. Now, a lot of you say, well, it's already written in cosine. That's the first thing y'all say. No, you need to write it with an identity. Now, the first thing I would think of is cosine of 2x plus x. Or you could do cosine of x plus 2x. That's what I would do. I would change that into cosine of x plus 2x. Remember the identities that we learned the other day? double number identities or whatever. I can't remember what they say. Cosine of A plus B.
Yep.
So go ahead and rewrite in terms of cosine of A plus B. I would pull those up. Cosine, cosines minus the sine, sine. Let me pull those. Well, let me just pull up that. We're going to take a second here. And cosine of 3x, rewrite it. And meanwhile, I'm going to go here. I'm going to pull up. Let's see how many clicks it does take. Trig identities. Okay, we have to type in those two words. That's a lot of work. And then images. That's the second button I clicked. And I'm looking for the green and white one. I don't know where it is, but
Mine was at the top.
yeah, of course. Mine's.
I think it's put in cheat sheet.
Okay, let me put in cheat sheet. So you're the one that did it. Okay.
I did.
Cheat sheet. Sheet.
You have to type it.
Yeah,
There it is. That's the one I use.
Then you go to Amazon.
So, and then you have to print. Yeah, you'd have to do that too, so. Oh, come on. There we go.
No.
Will it not let you print it out?
Can't you just print the picture?
There it is.
out?
Okay, so the cosine of, let's see, there it is. Not the periodic. So let's see, where is cosine? We just did them the other day. There it is. Cosine of A plus B, right down here. Sum and difference. Okay, well, I'm not going to worry about it. You figure out how to print it out. I'm not gonna fool with it anymore. It's done made me mad, and I'm pissed at it, so I'm not gonna fool with it anymore. But does everybody see the green and white one right there? You figure out how to print it out, and that's print out the front and the back. It's a very good cheat sheet to use for the test, and that's all I'm gonna allow you. No calculators. All you need is a pencil and a cheat sheet, and it has to be that one, or I'll give you mine. I got one that's laminated, and that's it. That's what the test is going to consist of.
Okay.
Yeah, paper test. We're going to do it the old-fashioned way. And there'll be proctors at the Pendleton campus, there'll be proctors at the Easley campus, and a proctor at the Oconee campus. So, cosine of 3x can be rewritten as the cosine of 2x plus a. Now, therefore, we have the cosine of A plus B. And the cosine of A plus B is equal to cosine minus the sine, right?
Yeah.
So cosine minus sine. And of course, we read from left to right, and that's A and B accordingly. So that's going to be the cosine of 2x, cosine of x, minus the sine of 2x times the sine of x. Now the cosine of 2x and the cosine of x, take your handy dandy highlighter here, that can be rewritten by the identities right there. And look at there, that can be rewritten as the identities over there. So go to it. This is what you call a nested problem. What is the definition of a nested problem?
This.
This, thank you. What is the definition of a nested problem?
Problem within a problem.
A problem within a problem. You have two problems in one. This one you have to break up into the sum and difference, and then you break up into the double angle or double number. So what are we going to use for the cosine of 2x? You're going to use the cosine squared minus the sine squared. And for the sine of 2x, you're going to use 2 sine cosine. And then guess what is after that? Nothing but 100% what? Algebra. So the cosine of 2x is going to be equal to and I'm going to write it in, I don't need to do that. Let me go back and highlight it in green, because if I write in yellow, the world will stop revolving and everybody will go, I can't see it, I can't see it. And I don't do that. So, and I'll hit pen, red, there we go. All right, so I can rewrite the cosine of 2x as the cosine squared of 2x minus the sine squared of 2x. So the cosine squared of 2x minus the sine squared of 2x. And I'll put that in green parentheses. And then I'm going to rewrite sine of 2x as 2 sine of x cosine of x. 2 sine of x cosine of x, and put parentheses around it. Now, it's 100% algebra. So I'm going to put a cosine.
Okay, wait. For the cosine of 2x, is that not supposed to be cosine squared x minus sine squared x instead of 2x?
I'm sorry. That's why I got my notes. Let me check and make sure I didn't. Should be cosine squared of x. Should be cosine squared of x. Thank you.
Okay. Yeah.
You're right. My mistake. Boop. Boop. Yep. That's why I write my notes, Hubert. And this is going to be sine of x. There we go. Now it's 100% algebra. So let's see how good you are. Let's see how good your algebra skills are. And I would say there's probably 4 to 5 steps left. Okay, I only see 5 people at the Pendleton campus. How many's up there?
10.
Okay, now I see y'all. Hello, left side of the room. And I only see an elbow and 3 people. I see an elbow and 3 people. Let's see, that's 9. And the other side, I didn't even see an elbow of a person. I think I saw a cord and looked like a phone. It's on the right side over there. But how are we doing, Pendleton? We doing okay? Doing. How about Easley? How we doing?
Good.
All right.
Oh, we got 2 people at the Easley campus that can talk. Wow. We're moving up in the world. We got 1 person that grunts at the Pendleton campus. We got 2 people that actually talk at the Easley campus. Of course, Miss Crittenden, she don't associate with us, so she's up there by herself. All right. Maybe I should just do like other teachers. Teach 5 or 6 sections of class and then hang up and say, see y'all. Maybe that's what I should start doing. What do y'all think? Just be introverted.
Maybe we don't do that.
No, let's do it. Let's see what we can, see what kind of class we can have.
Class where everyone fails.
I don't know if everybody's going to pass this one. All right. So I don't know if the introversion is going to work. It doesn't work in the real world, I can tell you that. So we got cosine what? Cubed x minus, and I'm just going to put sine squared x, cosine squared, or cosine of x. And then here, I'm going to get minus 2 sine squared x cosine x.
cosine sine.
Cosine
Yeah, it should
sine
be
X.
cosine sine x. Because you're distributing sine to cosine.
No. What's 2x times y?
Okay, never mind.
What's 2x times y?
2xy.
Okay, so you don't multiply it again. Yeah, you're just leave. Just leave the room. Make sure, check my notes. Cosine, yeah, sine squared, cosine. Minus 2 sine squared. All right, now what? Somebody tell me what the algebraic term is for the next step.
To cry?
Group.
Combine like what?
Terms.
Combine like terms, which would be cosine cubed.
Minus 3.
Good. I am impressed. Minus 3 sine squared x cosine x.
Okay.
Now use identity. I see an identity in there. Remember, what is the first rule of identities? Always write in terms of sine and cosine. How many cosines we got in this problem?
4.
We got 2. We got cosine cubed, and then we got cosine. All right, we got 2 things there that are cosine. What if we was to write the sine squared as cosine? What would that be? 1 minus what? 1 minus cosine squared. So rewrite the sine squared as 1 minus cosine squared. So, or quit, 3x minus 3 parentheses, and I'm going to take my green pen, and I'm going to rewrite this as 1 minus cosine squared x, and then cosine of x. People don't fail calculus because of calculus. People fail calculus because of algebra. You're getting a little taste of it right here. So distribute the cosine, and that's going to give you cosine of 3x minus 3 cosine of x plus what? 3 cosine squared what? Of x. Combine what?
Like term.
1 cosine of 3x minus 3 cosine of 3x is negative 2. Or let's see. That's supposed to be a cube. Sorry, I messed up. My cosine cubed x mutated into cosine of 3x. Y'all see that?
Yeah, it just kind of.
Can't have that. You can't do that. Okay, that's called a morph. What do you call it? Morph. Forget it. Morph. Cosine cubed x. Cosine cubed x. There we go. Can't let it morph into cosine of 3x. All right. So we've got cosine cubed x. This is cosine cubed x right here. There we go. And what is 1 cosine cubed x plus 3 cosine cubed x?
4 cubed x.
There we go. And 4 cosine cubed x minus 3 cosine x. Now, you could factor out a cosine, but that is in simplified terms. Okay? Now what you need to do now is look over what we just did. All right? First of all, the only thing new we will put in highlight of yellow. Okay, so we did change the cosine of 3x into the cosine of a plus b. Okay, so that's new. Okay, then we plugged in cosine a plus b. We did that. That's kind of new. So we'll write that as new. And then we did the green right here and the green here. Now, I don't know how you would do this, but 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 steps, and out of those 9 steps, 1, 2, 3, 4 of them are new. The rest is algebra. So you've got 60% algebra, 40% new stuff. And that's a good taste of what you're going to see in calculus. Now, when do you see all these identities and all this plugging and chugging? You don't start seeing that. You will see some identities in Calc 1, but that ain't where you're going to see them. You're going to see them in Calc 2 and Calc 3 and DiffEq. Calc 3 and DiffEq is where you're going to see most of them. And you're going to be plugging and chugging derivatives in also into formulas. Let's do another one. Let's do this with the product to sum. So I'm going to pull product to sum up, and we'll just make this another screen and pull product to sum. And move it over there. And we're going to do, make sure I got the right ones. Sine, cosine, cosine, sine, 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 cosine, cosine, sine. Yep. Let's do 2 sine of 58. 2 sine of 58 cosine of 102. Okay, the first thing, you don't have to find out where you are because you already know where you are. You already know 58 degrees, you know 102. That's not going to help you anyway. Next, you got to find, okay, which one am I going to use? Well, it says sine cosine. So I'm going to use sine of A, cosine of B. So we're going to use this one. So use that one and plug and chug. Now, why am I not worried about the 2? Because if you take this 2 and you take this and plug it in, that 1/2 and that 2 is going to what? It's going to cancel, and that's going to happen on most of your problems. Okay? So just focus on the sine of 58, the cosine of 102, and plug and chug. Now, you're not going to really get down to a nitty-gritty decimal or anything like that. You're just going to get to a simplified version. So that's going to be 1/2, 2, I'm just going to rewrite it like this, 2, and then I'm going to put 1/2 sine of 58 plus 102. I'm going to put that in brackets, plus the sine of 58 minus 102. And that's going to give me 2 times 1/2 brackets sine of, what is that, 160? Plus the sine of negative what? I have no idea. 58 minus, what is that, 46? What is it, 44? What is it? What's 58 minus 102? Where's my notes? No, it takes y'all too long. Negative 44. And y'all give me the wrong answers on purpose so I don't fool y'all. So sine of, what's 2 times 1/2? That goes out. You're left with sine of 160 plus the sine of negative 44. Wait a minute, Hubert. When you have the sine of a negative angle, you can rewrite that as a negative sine. Yes, you can, class. So that would be sine of 160 minus the sine of 44. That's your final answer. So on this problem, you didn't even use any algebra hardly. You only used nothing but plugging and chugging. The only new stuff that you used was you used plugging and chugging into this formula, and you used the negative identity right here. You put the negative out front.
And if it was minus sine negative 44, it would just switch to a positive instead?
Yeah. Now the sum to product, we'll do that next. Yeah, let's go ahead and do sum to product. Let me pull that up. Sum to product. I'm going to let y'all do this one. Cosine of 4x minus cosine of 2x, sorry. Cosine of 4x minus cosine of 2x. I wouldn't even try it, I'd quit.
You make a convincing argument.
Yeah, just don't even try it.
Blame it on the Russians. It's all their fault, you know.
So does anybody follow boxing? Anybody have any idea about Fury and Deontay Wilder? Okay.
No, I do not.
I guess the only way to communicate with this generation is talk about Fortnite.
Yeah. What do you want to talk about Fortnite? Take some.
Credit to myself.
I never even played.
At least we know where the intelligence of our future is going.
Video games.
So which one does it look like? Well, golly, it looks like the second one. You reckon? So that's going to be equal to negative 2 sine of A plus B over 2 times the sine of A minus B over 2. Because it's the cosine of A minus B. So it's going to be... Now, if you've ever had trig before, you know that there are some teachers out there that make you memorize this stuff. And that's why people fail. Because that it's not because of this. It's not because that you don't know how to plug and chug. It's just because you're trying to memorize it. And I'm not going to do that. So you're welcome. You're welcome, Pendleton Campus, so I'm not making you memorize it.
Aw, thank you.
One person, thank you. Appreciate that one-person interaction.
You're probably going to be tranquilized, though.
It's the most valuable kind, one-on-one.
What?
It's the most valuable kind.
I know.
They're
So,
probably going to be tranquilized.
Let's go with equals negative 2 sine of 4x plus 2x over 2 times the sine of 4x minus 2x over 2. And that's going to be negative 2 sine of 2x, or 6x, over 2, times the sine of 2x over 2. Negative 2 sine of 3x. I am amazed. A role model. What else?
Robot.
A robot.
Robot? I don't know about that. He may be Russian. May be sent to infiltrate and get a van, rent a van, beat you up, throw you in the back of a van, and make you vote for somebody who you don't want to vote for.
I'm
That's
associated
wonderful.
with-
Unless you're a white woman, and if you're a white woman, you're dictated to by your husband who to vote for. Yes,
Oh, no.
What?
Okay, let's try nerd.
I'm excited for a nerd.
What?
I said I'm excited for a nerd.
Yeah, whatever, nerd. You'd be surprised on how difficult people make these problems. Let me tell you. I had a trig teacher. Oh my gosh. We won't even talk about it. And then I had to talk to Harden. Sine of 2 theta minus the sine of 4 theta. Plug and chug. Now I'll give y'all a hint. It's the 4th one.
But you don't say.
Now do not let your thetas morph into zeros. That will cause you a big problem. So that's going to be 2 cosine of 3 theta and sine of what? Negative theta? But that's not the final answer. 2 cosine of 3 theta minus sine of theta. Question on that one. Next one is the half angle identities, or the half number identities. And what I'm going to do is I'm just going to let you do it, and I'm not going to even show you anything, just to show you how easy they are. So, half number and we're going to do cosine of x over 2. So right there I'm telling you what to do. Cosine of x over 2 given cosine of x is equal to 1/4 and x is between 0 and pi over 2, which means that it's what? In the what quadrant?
First.
First quadrant. So that means that cosine is going to be positive. So go to it. You're going to use, for those of you that need to know, you're going to be using the second one. This right here dictates that you're going to be using this one. Therefore, you go back over here and you say, okay, we know it's positive, so it's going to be in the first quadrant. And that's going to be 1 plus 1/4 over 2. Now, I'm not no rocket science, but that to me is not very difficult. It tells you which one with the x over 2. That means cosine of x over 2, you're going to use the second. Cosine of 1 over 4, cosine of x is equal to 1/4, so therefore you know which one to plug in right here. Cosine of is 1/4, cosine of theta is 1/4, cosine of x is 1/4, and then it's in the first quadrant, so you know it's going to be positive. So that's going to give us square root of 5/4 over what? 2 over 1, multiplied by 1 over 2. The square root of 5 over 8, which is going to be the square root of 40 over 8, which is going to be equal to square root of 10 over 4. Somebody check me. Question, gripe, complaint.
I'm not sure how you got from to
He
the square root of
multiplied
40.
it.
I was waiting on the question. And I know Pendleton's not going to ask it, even though there's probably 3 or 4 people up there that don't know it. But you can't leave a radical in the what? In the denominator. So this right here is equal to the square root of 5. Okay, can I finish? Can I be in charge for a while?
Nope.
Square root of 5 over the square root of 8. Square root of 5 over the square root of 8. Multiply by the square root of 8 over the square root of 8, because you don't want a radical in the denominator. And that gives you the square root of 40 over 8. But 40 can be written as a perfect square, and that perfect square is the square root of 4 times the square root of 10. Square root of 4 times square root of 10 over 8. The square root of 4 is 2, square root of 10 over 8, and 2 and 4, 2 and 8 cancels till you get the square root of 10 over 4.
Okay.
Mr. Hubert,
Yes, sir.
so you always have to do the reciprocal for the 2 over the 1 to get
Yes.
cancel it
When you
out?
multiply, when you divide by a fraction, you multiply by the reciprocal. That is 100% all the time. Thank you for asking. Anybody got another question? I hope they're not going to jump on you outside, are they? When you go outside Pendleton campus, they're not going to jump on you and beat you up, are they?
Hopefully not.
Okay, I hope not. They didn't beat you up yesterday, did they? Guy in the maroon shirt, they didn't beat you up, did they? Okay, so that means that y'all can ask questions and talk. Nothing bad will happen to you. So that's a good thing. Thank you for asking. All right, what else? Anybody else got a question? Okay, now you've got 9.1, 9.2, and 9.3. I've assigned those 3. I don't care about 9.4, okay? I don't even know if I'm going to test you on 9.4 yet. Everybody with me? So everybody needs to, Wednesday, I want you sending in questions for 9.1, 9.2, 9.4. I do realize that some of you have sent in a couple of questions. I do realize that. But I want everybody to be on the same sheet of music. I just covered all the identities that I'm going to test you on with 9.1 through 9.3. So that means that after Wednesday, we probably will be having a test on 9.1 through 9.3. Why am I testing you different from the outline? Because this part is very, very, very important. 9.1 through 9.3 is very important for your calculus classes. All right? So I want to make sure you know that. There's some things in chapter 9 and 10 that are not that important. This is. 9.1 through 9.3 is. So I want to make sure everybody has like a 90 or above understanding on it. So Wednesday, we'll go over homework problems. So make sure you send them in, whatever, Thursday. Make sure you send them in, okay? Anybody got questions for me? Wait after class. The rest of y'all can hightail it, work on that homework. I've already assigned it, so everybody's good. Questions? All right, y'all have a good day.